So this is in fact an actual array of plane polarized light. The light is polarized in one particular direction, the electrical part in one direction and the magnetic part in another plane. This may put a query in our mind that what happens with the plane polarized light? To be frank, the light that is propagated is in general in all 4 pi directions. So it is in non-polarized light. But we polarize this light by passing it through a Nicol prism, means we actually try to polarize the planes. This picture is in fact this plane and this plane, they are polarized. Now the magnetic plane in one plane and electrical in one plane. So this is a true example of a polarized light. Let us try to understand this phenomena graphically. The propagation of plane polarized light. The two planes are shown in different shades. One little gray and another dark, that is black. The propagation of the two fronts is just right angle to each other. They are propagating, one arm moving, another arm is also moving. So this propagation is, the both coordinates are at right angle to each other. When they enter into a solution, the one of the part is stopped or released by the medium and the velocity changes. So the observer finds one arm earlier than other and he says that the ray has rotated. This is what is observed as circular dichroism or polarization. I'll go into details of this phenomena later on in some other lecture, but this is just an introductory part for a plane polarized light and its propagation. We now may come to the total observation that what all regions that are thrown by this cosmos or the sun towards earth or a human being or any matter, these are the different parts, regions. The electromagnetic radiation, we have energy, we have frequency, we have wave number and the wavelength. It begins with the cosmic wave. These rays are produced by highly oscillating particle. The velocity of that oscillation or the frequency of that oscillation is thousands and thousands in 1 second. So the waves that are formed are very small, but the energy is very high. So if you look at the energy, it is very high, but the lambda wavelength is very, very small, some 10 to the power minus 10. Next is the gamma ray. They are slightly larger in wavelength because they are produced by slightly lesser oscillating particle than the X-rays. Again, the wavelength has slightly increased, some 10 to 20 folds to that of cosmic rays. All these rays are very, very harmful for the body. They have very high energy, they have very high penetration power and can even volatilize anything in the universe. Next comes the ultraviolet. This is you might have heard of this ultraviolet. These are the radiations that are stopped by the environment. They don't reach Earth. Second is the visible, which is in fact the total constituent of the visible world that a human man can see, a human being can see. This has VIBGYOR, violet, indigo, blue, green, yellow, orange, red. This word is also composed of 7 alphabets and the VIBGYOR is also composed of 7 alphabets. They decrease in energy because the wavelength is gradually increasing. Since the wavelength is increasing, that means the particle that is oscillating has slowed down. It is taking a larger time for one oscillation. So the lambda that is formed is also small. If we go to the next, it is far end of the visible, that is violet, indigo, blue, green, yellow, orange, red. Next to red is infrared. These are normally used as heat waves. You might have seen at some doctors, they use a red lamp for heating your body organs. These are the infrared lights. These are the infrared radiations. You might have also seen a heater glowing red when turned on. This is because it is reading infrared light or the heat radiations. This infrared and the coming part is in general used for satellite imaging also for the Earth. Next is microwave. these are very low in energy, very large in lambda, because they are created by particle oscillating at a very low speed. The particle is oscillating some 10 or 100 times in a second, so wavelengths are formed are also very large. Since the impact is low, their energy is also low. You can very well sense these waves when you go out in the sun and your body feels warm. This feeling of warmth by the body is because the sun rays is emitting microwaves that react with the compounds present in our body, they vibrate and the heat is transferred. So we feel the heat. This is because of microwave. You also might have heard of microwave ovens. These microwave ovens are actually based on the vibrations of some greenhouse gases such as carbon dioxide, water, and some hydrocarbons. These two molecules, on account of microwave radiations, are actually responsible for heating of this environment. As you know, if you go little high in the atmosphere, it becomes cold. But how come the earth is hot? Because the radiations that enter into the atmosphere with the interaction with that environment, they vibrate these molecules on the part, these molecules, they emit heat and the environment is hot. We are lucky enough to have these two molecules on earth, so we are in an hot temperate climate. Otherwise we would have become Jupiter or Mars. The entire environment would have gone down cool to very high extent where the life would not have been possible. Anyway, this is a matter of discussion, but this is just an example how these microwaves transmit radiations to earth. They keep the greenhouse effect active on this earth. Next is the radio waves. These radio waves are so large in wavelength that the wavelength ranges from kilometers to even 1000 kilometers. If a crest falls at this point, another may fall, say, beyond a hill. These rays are in general used for telecommunication. As regards the observer, you might have seen very large dish antennas kept at hillside, on a hilltop by roadside, because since the wavelength is too large, this is collected by large antenna. Look, the antenna becomes an observer. If the radio waves are large, the antenna is large, the observer is large. If you go backwards, microwave, infrared, visible, UV, X-ray, the rays are decreasing in lambda. So size is decreasing. So the observer should also decrease. This is how the observer changes when you go from microwave to infrared, infrared to visible, up to visible or infrared. The body is sensible enough to understand. We have so far discussed two aspects of the lecture. One is matter, how all it is composed of. Second is the radiation, which is electromagnetic radiations, the different regions, their energies, frequencies, wave numbers and wavelengths. We now come to the third part, that is interaction. As the word interaction stands, interaction means, interaction is to act on each other. That means the matter to influence radiation or the radiation to influence matter. To memorize how many types of interactions can be, I have given an alphabetical help. A, D, E, P, Q, R, S, T. Luckily, the P, Q, R, S, T are the normal words, alphabets that appear in the English alphabetical sequence. A stands for absorption, D for dispersion, E for emission, P for polarization. Q has been inserted because, see, there are certain stimulated energy radiations which are caused by large amplification or microwave amplification, which were earlier called as quantized radiations, are considered as Q. R for reflection or refraction, S for scattering, and T for transmission. If you look at this absorption, if a ray falls on a matter, the ray enters into the matter and the energy is absorbed by the internal contents. So they increase